course, many of those who are against wind farms, for instance, point to the very high level of subsidies given to those who allow them on their land, etc. And I think there's something in that, because I would far rather see those funds spent on R&D into new kinds of energy. I think in the long run, wind is going to be part of the solution, but not all of the solution. And I think we in this country in particular, if we are going to make a difference to the world, are more likely to make that difference by innovation and new technology, because we are at most 2% of the world's problem regarding CO2 emissions, whereas we perhaps have more than 2% of the ability to solve it by accelerating new technologies. So I would be in favour of the government supporting research into new energy sources, and it's a pity if they have to take this from subsidies, but that's better than nothing. But I think the main point I would make is that the level of R&D into clean energy is really very low. Why shouldn't it be on the same sort of level as R&D in health or in defence, which is far higher? And so that's why I think that one ought to be able to fund our CCS demonstration plant, as well as increasing the funding into other kinds of clean energy in this country, because there's a long-term economic benefit to us if we are the pioneers of these.
Most of clean energy will be electricity. I mean, perhaps we might develop hydrogen powered cars, but probably most of our clean energy will be in the form of electricity. And yet, when you buy a new boiler to heat your home, it will be a gas boiler, and you'll probably get some kind of discount if you're replacing your old inefficient gas boiler with a new, more efficient one. There is no question that you will put a new gas boiler into your house. Yet, presumably sometime in the next 10, 15, 20 years, we're expecting not to be burning gas anymore to heat our homes. Yet, when will we stop being required to heat our homes with gas? That's the only way to heat your home now, really, with gas.
Yes, but it only makes sense to abandon gas boilers if the electricity is generated some way other than by coal or gas.
But if we set in place a program to say, right, our target is to be weaning people off gas in their homes in the next 10, 15, 20 years, well, I, for one, would be pleased to see that, and I would think, right, our boiler needs to be replaced quite soon. I'm going to get an electric system because I can see that's the direction we're going. We have no direction at all.
No, but is it realistic to go over to completely clean energy in this country in less than 20 years? I don't think it is.
And if we don't, then what does that mean for the Paris COP21 outcomes? I mean, surely they're much weaker if we don't have a target of the next 20 years.
Well, indeed, and that's why I think it's unlikely that the targets will be met. And even if they are met, then it's not clear it's going to be sufficient to eliminate the risk of long-term climate change. I think we have to be pessimistic about the realistic outcome of this. But I think the way in which we react to Paris and the climate policy in general depends very much on ethics and economics, because everyone would agree, unless they're complete climate skeptics, that there's going to be a potential very serious risk 100 years from now from runaway climate change. And the question is, what insurance premium are we prepared to pay now in order to remove a risk from people 100 years from now? Conventional climate policy says we apply low discount rates and we do care about future generations. But if you adopt a standard discount rate, then of course you don't pay any regard to what happens more than 40 years ahead. And so I think the debate about climate policy is more debate about ethics and economics than about science. And I mentioned Lomberg and the Copenhagen Consensus. Their view that dealing with climate change is low priority is simply a consequence of their assumption of a standard discount rate, which may not be the appropriate discount rate in this context. And many people would say that in this context we should not discriminate on grounds of date of birth and take account of what will happen in the lifetime of people just born today. And that is the basis on which you decided it is worth paying a premium now.
And the research that we ought to be doing in order to protect future generations, we're just not doing enough. We're not exploring the full realm of possibilities for solar in the UK, for modifying the grid, modifying energy storage. We should be doing far more, shouldn't we?
Well, I think we should. I think, and this is where the government should be spending far more, let's say, in R&D, on the level of R&D into health and defence, and fostering infrastructure projects which are going to be essential preliminaries to this transition, because the private sector left to itself is going to apply the standard discount rates, which aren't going to give enough weight to the long-term future, obviously. So I think it is a matter for governments to take the lead. Obviously, it's hard to persuade governments to do this, but I think the upside is if we develop new technologies, then this can be a real asset, and that's where this country has a possible competitive advantage.
But we're investing in fracking technologies. That's where the research seems to be. That's where the interest seems to be. The future of decarbonisation seems to be pretty uncertain.
Well, that's right, because its benefits are longer term, whereas the fracking might come sooner. But of course, even that's not clear, is it? Because the situation may not be as positive here as it is in the United States.
And does fracking releases methane? And we're only really now beginning to account for the importance of methane, or is that overrated? But methane's quite a potent greenhouse gas.
It is. The question is how much is released. But of course, that reminds me of another point, which is that as a consequence of Paris, it's very important to emphasize that there are minor contributors to greenhouse effects, black carbon and pollutants from power stations, and it's easier to motivate action to deal with those, because as well as having the diffuse long-term global effect which a rise in CO2 has, these have short-term local effects, as are extremely serious in Chinese cities, for instance. So they have a strong motivation to cut down on those short-term local pollutants, which also are contributors to greenhouse warming.
We're not going to change the way we live our lives until climate change has a direct and serious impact on our lives. Now in Fiji, climate change seems to have had a very dramatic and direct impact on their lives this week. Well, that's a long way away, geographically, culturally, from us. We really just don't seem to care. And that's tragic, it's terrible. But as long as the weather's nice and the daffodils are coming out at roughly the right time of year, we're going to be quite happy with our lifestyle, and we're not going to change our ways.
Well, that's why it's so important, because I think that many people in the developed world are influenced by the Pope, even in the American Republican Party. And so I think it's very important to ensure that that sort of message does get traction, and that we care about the global environment. We're all on this small planet together, and also that we care about the poor. And as regards the justice between the developed nations and the rest, clearly we are indeed the cause of the problem. And I think we therefore have an obligation to transfer wealth towards the underdeveloped countries. And I think given the urgency of the problem there, that's got to be in supporting their adaptation.
But the aid to poorer countries that will be affected by climate change that was agreed in Paris, well, it's not going to go very far.
No, because I think the total amount spent worldwide on energy and associated things is several $1 trillion a year, isn't it? So in that perspective, this is very small. But nonetheless, I think it's important that we should be prepared to subsidize adaptation in the countries which are most vulnerable.
While at the same time not changing our habits at all and burning fossil fuels as if there was no tomorrow.
Well, we should do that too, but I think that in the short run, we've got to ensure that there's adaptation, because just as in the case of quite different natural threat earthquakes, we know that if you build buildings better, you can hugely cut the casualties in earthquakes. Yeah. And similarly, adaptation can make a big difference in countries where people are now especially vulnerable.
I'm worried that this being an El Nino year, the Fiji cyclone will be seen as an El Nino phenomenon,
well,
and nothing at all to do with climate change.
Yes.
Of course, we can never know. We can't actually attribute a particularly strong storm to climate change. And as long as we have these natural variations, El Nino being one of them, that's kind of a get out for us to deny that climate change is really that important.
But still, we should help them to adapt to them, whatever the cause is.
Whatever the cause. And how are we going to use events like the cyclones in Fiji as evidence that we ought to be changing our behaviour? And I suspect that we will continue to find excuses for not changing our behaviour.
Well, of course, the science is still pretty uncertain on the extent to which these storms are aggravated by climate change up to now. It's probably the case, but it's a hard thing to argue at the moment. But I think that's why we've got to clarify things, and also, of course, in measuring the effect of climate change up to now, not just look at the global temperature rise, but look at the energy stored in the oceans, which is going up steadily. And that is perhaps the best measure of climate change. And also, we should improve the global coverage of weather patterns to see what the changes are, because it's all these indicators which are going to be important in deciding the rate of climate change due to anthropogenic effects. And we need therefore to improve this. And that'll be important, obviously, in motivating countries to do something about it. Well, I think we should welcome Paris, because it was important to get this statement, and even more important to get the agreement to reconvene every 5 years to update pledges and see what progress has been made towards them. That ensures that the topic does not slip too far down the agenda. That's good news. But I think it is unlikely that the pledges are going to be met, and even if they are, it's unlikely that'll be enough. And that's why I am rather pessimistic about this whole topic. I think we don't yet know, of course, just how sensitive the climate is to CO2. There's an uncertainty in this sensitivity factor. And my expectation is that not enough will be done in the next 20 years. 20 years from now, we will know, both from better science and also from a longer time base, just how fast the temperature is rising, just how fast the ocean is heating up, and all these things. And if it is on the low side, then people will relax. If it's on the high side, then there will be pressure for panic measures, as it were, and these are going to include geoengineering, because we're going to realize it may be too late to actually stop runaway climate change to tipping points.
And that's going to introduce something. Even in 20 years' time, that'll be too late for geoengineering then, I think, because we won't have done the R&D on geoengineering, and it'll take another 20 years to get the technologies working.
Well, I think for just that reason, we should be doing some research on geoengineering now.
Well, we're not going to, because people are fearful, for all sorts of reasons.
Well, I know they say
that geoengineering is something evil in some way.
Well, I rather agree with his statement, actually. I think we should do R&D, but of course the worrying thing about geoengineering is that it could be done by a single nation or even a single corporation to an extent that might actually affect the climate, and we don't understand the climate well enough to know what that effect would be. Of course, we may end up with sort of litigation with different countries blaming each other for changes in the weather, etc. And so I think it is probably right to have a moratorium on any country attempting to do something in the stratosphere. They won't do this now, but it's the kind of thing that might happen in 20 years' time. And if it happened, then it might indeed do more harm than good. We can't be sure. But it's all the more important, therefore, to start straight away doing R&D into what is feasible and what isn't. It may turn out that it's not feasible, and then we'll have to redouble our efforts to make sure we never need it.
It's going to be cheap, I think, to do geoengineering. And something that's cheap is going to be attractive in all sorts of ways to politicians, to private companies. It may be of the order of a few $1 billion, the cost of a nuclear power station, to produce a 1 or 2 degree global average global cooling.
Yes.
Now, what we know about geoengineering is that there are going to be winners and losers. In the same way already, we see winners and losers with ordinary climate change. The polar regions are much warmer than they used to be compared with other parts of the world. Storms in Fiji. Well, geoengineering will have its own problems, its winners and losers.
Yes.
We've got to look carefully, very carefully, at what the potential is for geoengineering and what the hazards are. And without research, without well-funded research, I suspect in 20 years' time it will be done in a very dangerous way.
Well, absolutely, and it's true that it's going to have winners and losers, but the difference is that if it's done artificially, then there's a new blame game.
Yeah, absolutely.
And those only gainers are going to be the international lawyers, and it's not going to help. But I think what we need to do is to see which techniques are feasible and which aren't, and also to understand the climate well enough to know the regional impacts, because we still don't have very good data on the regional impacts of natural climate change, and still less do we know what would happen to the climate if you injected stuff into northern hemisphere, but not the southern hemisphere, for instance. And of course, the other important point is that any kind of geoengineering of that kind, the kind where you put stuff in the stratosphere, is storing up problems for the future, maybe buying you time, but it's not going to stop the inexorable rise in CO2, which affects ocean acidification and all those things. So those are reasons for not regarding it as a panacea. But nonetheless, we should study it now.
But if we need to buy time, and my fear is that we will end up doing too little too late, we probably will need to find a way of buying ourselves time. Geoengineering might be a useful tool, and we ought to research it. My feeling is that warming of the Arctic is perhaps the biggest, most immediate concern of climate change. If research can be done to demonstrate that we can find a way of cooling the Arctic, slowing down the melting of the Arctic, that might be something that we could all agree on as something worth doing.
But we have to be sure of the models to realise that
we
knew what to do to the stratosphere in order to ensure that happening.
But we could consider doing some relatively small-scale experiments to help validate those models. At the moment, there is a moratorium, as it were, on injecting anything into the stratosphere.
Yes.
I kind of like the idea of injecting a very small amount of material into the stratosphere so that we can validate the models. With better models, then we can start to look at whether geoengineering is at all useful or not.
Yes, yes.
But without good models, without validated models, we'll never know.
Yes, we need better computer models. It's not clear to me that by injecting a small amount, you would clarify what happened if you injected a large amount. It may not be a linear effect. So
it may not
yeah,
be,
yeah.
but this is where the research needs to be done, and you can start to demonstrate if there is a linear effect. For example, we know what happened when Mount Pinatubo erupted. So we know what happens with a large quantity of sulfate aerosol. Perhaps then if we put in a small quantity, we can check the linearity.
Yes.
The models
Yes.
are nonlinear. The models are complicated. But without measured data, or with very little measured data of how
Yes.
the planet responds to geoengineering, we will be in the dark. And in 20 years' time, I suspect government will come along and say, look, we desperately need to refreeze the Arctic. Let's do geoengineering. Fine, but we'll be doing it without the benefit of having done 20 years of research.
No, I agree we should do research. I mean, I'm slightly concerned about how much you could learn back to direct experiments up there. We ought to understand the technology for doing it.
Well, the direct experiments, I think, we don't know enough about ozone chemistry. We can observe if we inject a small cloud of sulfur dioxide, let's say, or whatever other material.
Well, you need to do
might
experiments
have.
to decide how it diffuses and how long it stays up there, obviously, but experiments with a view of making a small tweak in the climate, I would slightly worry about.
Well, I would worry about an experiment to make a small tweak in the climate. I personally don't think sulfur dioxide is the right material even to be looking at for climate engineering, because we cannot predict the potential long-term damage that might cause. I would rather we chose a dust of some sort, which is chemically inert, that won't affect the chemistry of the upper atmosphere. But we need to do the research.